So these are the last set of 5 sums. You must not think quadratic equation will have always x. It will have even y, any variable like y, m, a, p and all. When it comes in y, it's called a quadratic equation y. So first we check whether the first sum it's a quadratic equation. So you must bring it to the standard form. So don't disturb the 2y square. So write the 2y square, bring these two numbers this side. It will become plus 3y minus 4 equal to 0. This is of the form ay square plus by plus c equal to 0. So this is a quadratic equation in y. This is a quadratic equation in y. So it's not necessary it should have always x. Any variable or any alphabet like y, p, m, a, anything can come. Okay, so this is a quadratic equation in y. All the sums, the 10 sums we saw was a quadratic equation in x. Generally they give the format ax square plus bx plus c equal to 0, but it's not compulsory. Sometimes they change the variable as y. This varies thing. Now the first one is a quadratic equation in y because it is of the form ay square plus by plus c. We'll try the second sum. So second sum deals with a variable called m. Root of m plus 4 equal to 4m minus 3. This you must put as one number. Or okay, write the question first. Next step we'll put it. Now look here. We have to check whether it's a quadratic equation in m. So when root comes, you square both sides. You write what? Squaring both sides. Whenever root comes, you must square it. Root of m plus 4 the whole square is equal to 4m minus 3 the whole square. You must use the formula a minus b the whole square. And you know a minus b the whole square equal to a square plus b square minus 2a. So we have to square both sides. When you square this side, the root and the square cancels. So you get m plus 4 equal to 4m the whole square is called a square plus 3 the whole square is called b square minus 2 into 4m into 3 is called 2ab. So when you square both sides, to remove the root you have to square both sides. So what you get is actually is m plus 4 equal to, when you square this you get 16m square plus 9. Here you must multiply the numbers first. Put the sign first. 2 4 8 3 is 24m. So bring it all one side. You can take these two that side. So write the 16m square first minus 24m, and remove this, take that side, minus m plus 9 minus 4 equal to 0. So again I repeat, this m square term don't disturb. You write this plus 9 and minus 24. These two you take that side, it will become minus m and minus 4. Now look at 16m square. When you add this, it will become minus 25m. 9 minus 4 is plus 5 equal to 0. This is of the form am square plus bm plus c. This is a quadratic equation in m. This is a quadratic equation in variable m. Again I repeat, root of m plus 4 equal to 4m minus 3. To check whether it's a quadratic equation, when root comes you have to square both sides. So root of m plus 4 the whole square equal to 4m minus 3 the whole square. So you must write the formula a minus b the whole square, which is a square plus b square minus 2ab. So when you square this, you get m plus 4, the root goes off. So it becomes 4m the whole square plus 3 the whole square minus 2 into 4m into 3. M plus 4 equal to, you get 16m square plus 9. 2 4 8 is 24m. 24m. So you get this m plus 4, you take that side and don't disturb this 6m square. This will come as it is. These three terms will come as it is and take this that side. So 16m square minus 25m plus 5 equal to 0. So this is a quadratic equation in m. We'll try the next sum. We'll do the third sum. The third sum says 2y minus 3 by y equal to 7a. Don't get frightened about the word a here because there are two variables here. First we will try to bring it to the standard form. So 2y you put by 1, the LCM is y. When you take LCM as y, this will go there. You get 2y square minus 3 is equal to 7a. You can put by 1. Now you cross multiply. You get 2y square minus 3 equal to 7a into y. You get 7ay. Write the y square first. Next write this y term minus 7ay minus 3 equal to 0. This is of the form ay square plus by plus c equal to 0. Note here, a is called 7, b is nothing but minus 7a, c is nothing but minus 3. So then don't get frightened about this word 7a. It's another alphabet, but you try to bring it to the form. You get y square, a y and without y. So again I repeat, y square term, this is y square term, this is y power 1 term, and this is without y, constant. So when you get like this, it's a quadratic equation, irrespective whether you have some number 7 or even 7a like this. So it makes no much difference. Hope you got it. For example, you get this answer like this, 2a square minus 7a by y plus 3 equal to 0. This is also a quadratic. Look here, you got a y square term, you got a y term, you got a 3. This is called the coefficient by. This is called the coefficient ay square, okay, plus by. This is called the constant c equal to 0. So don't worry about any other unknown, one more variable coming, but you just check whether you get the standard form. It's not, always a number should come, even 7a like that can come. So this is a quadratic equation. We'll try the next sum. Next sum, look here. A by 3 plus 3a, plus 3 by a plus 3 by a equal to 7 by 3. Now look here, this 3 and a are called LCM. So the LCM is equal to 3a. If you want, you can take the LCM and then cross multiply. Another method is you can multiply the number by 3a. So again, look here, this denominator 3a and 3 are really headache. So to remove the denominator, you can multiply by the LCM also. That's much more easier. Look here, 3a into a by 3 plus 3a into 3 by a equal to 3a into 7 by 3. One step, if you multiply by the LCM, the denominator vanishes. See, look here, this 3 gets cut off, denominator gone. Again look here, a is gone. Again look here, 3 is gone. So all the denominator vanishes. Or you can take the LCM and then cross multiply, but this is also much more easier. You can take the LCM and multiply. Now a into a is called what? A square. 3 3s are called what? 9. A into 7 is called 7a. Bring the 7a this side and write a square first minus 7a plus 9 equal to 0. This is a quadratic equation in a. Equation in variable a. So again I repeat it, a by 3 plus 3 by a is 7 by 3. For 3a and 3, the LCM is 3a. So you have to remove the denominator. For that we take the LCM. So the one method is you can take the LCM and cross multiply, or you can multiply all the 3 fractions 1, 2, 3 by the LCM 3a. When you multiply all the three fractions by the same LCM, the equation remains balanced. It won't change. So 3a into a by 3, 3a into 3 by a equal to. Remember 3a you must multiply both left hand side and right hand side. Many they multiply left hand side and stop here. Then the equation changes. If you multiply by same number 3a, it won't change. First the denominator 3 vanishes, a vanishes, this 3 vanishes. So straight away you get this easily, you get a quadratic equation. And this is a quadratic equation in A, and you will check the last sum. So how to check whether it's a quadratic equation? Now you understood, you must bring it to the standard form. You can know it. So you can try the sums again slowly, you can to understand well. So look at this, the last sum. P minus A by P is equal to 8P. Now don't worry about this A. It's not necessary always you must have some number. So this is PP and one more variable A. So what we do is you put this P by 1, the LCM you take as P. Now we'll take LCM as P, this will go there. So it will become P square minus A equal to 8P. Or you can write 8P by 1. When you cross multiply, you get 8P square equal to, this will become P square minus A. Bring all one side, you get 8P square minus P square plus A equal to 0. 8P square is called 7P square plus A equal to 0. This is a quadratic equation in P. Quadratic equation in P, because you got a P square term. You may ask me, there is no P term. If you want to write like this, 7P square plus 0P plus A equal to 0. So this is called constant. Okay, this is called 8P square plus BP plus C. So again I repeat, P minus A by P equal to 8P. You write P means P by 1 minus A by P equal to 8P. Take P as LCM, this P will go and multiply that, and this will become minus A equal to 8P by 1. Now when you cross multiply, you get 8P square equal to P square minus A. Bring all one side, it will become 8P square minus P square plus A equal to 0. Remember, like terms you add it. 8P square minus P square will become 7P square plus A equal to 0. This is also a quadratic equation P, though the term P is missing. If you are very particular, you can write like this, 7P square plus 0P plus A. 0P is no P at all, but yet the P square term is there. So this is of the form AP square plus BP plus C equal to 0, which is a quadratic equation P. Now